Poisson, 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 Poisson.
So now
Poisson.
Poisson. Now it's better. So wait until I use my older headset. I'm using this old version of headsets, and those are the only I was using only a microphone. That was why I'm not used to. So that was why the sound I couldn't hear that sound, and for you was so now Poisson. So what is Poisson? Poisson. Let's start. Let's paste it here. Poisson meaning is well discrete probability distribution. That was the topic. I had it read it on my notebook. Discrete probability distribution. Does Poisson probability Poisson probability distribution and a Poisson probability distribution. What is Poisson probability distribution? I guess we will talk in this same chapter because they are learning objectives. No, I don't want to log in. Recognize the well, that was what I said. Recognize the geometrical probability distribution and apply it appropriately. Recognize the hyper geometrical probability distribution and apply it appropriately. Hyper geometric probability. That's new. That's something new. Classify discrete word problems by their distributions. Classify discrete word problems by their distribution. So here's an example. A student takes a 10 a 10 question true or false because the student has such busy schedule they could not study and guesses randomly at each answer what is the probability of the student passing the test with at least 70%. The manager of an auto dealership might be interested in the color preferences for new car buyers. Suppose on average the dealership sells 20 cars per month. What is the probability that a customer prefers red cars? Dealership, suppose a average of 20 new buyer. These two examples illustrate two different types of probability problems involving discrete random variables. That's variables. Recall that discrete data and data that you can count and random variables describe the outcomes of a statistical experiment. In words, the values of a random variable can vary with each repetition of an experiment. Random variable notation. Random variable notation. Uppercase. I don't want to subscribe to this website. Don't bother me anymore. Add uppercase letters such as X and Y uppercase denote a random variable. Lowercase letters like X or Y in lowercase denote the values of a random variable. If X is a random variable, then X in uppercase, then X is written in words as and X is given as a number. For example, let X equals the number of heads. You can let's zoom in a little bit. This seems to be nicer. I can read. Denote a random variable lowercase. Now we already read that. For example, the let X the number of heads. So I will stop. The number of heads when you toss three fair coins. The example space for the toss of three fair coins is TTT, tail, 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 head, head, tail, head, tail, head, 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 tail. head, tail, tail, head, tail, head, tail, 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 head, 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 head. Then it's equals to 0, 1, 2, 3, x, 0, 1, 2, 3, 3 possible in is in words, and x in lowercase is a number. Notice that for this example the x values are countable outcomes because you can count the possible values that x can take on the outcomes are on and the outcomes are random. The x values 0, 1, 2, 3, and I guess this is so on and so forth. It will continue. X in uppercase is a discrete random variable. Collaborative exercise. So, let's go through this. Collaborative exercise. Toss a coin 10 times and record the number of heads after all members of the class have completed the experiment, tossed a coin 10 times and counted the number of heads. Now fill in table 4.1, let x equals to the number of heads and 10 toss of the coin. X, frequency of x, relative frequency of x, so it's empty. Which values of x occurred most frequently? If you toss the coin 1000 times, what values could x take on? Which values of x do you think would occur most frequently? And what does the relative frequency column sum to? So that will be. This is a collaborative exercise, but I want to see the results. So the question is, which values of x occurred most frequently? But I don't know. It's this introduction, but I'm not doing it. I don't have the time. Let's go to the content and 4.1. That's, but I guess now they have an example that is already solved. A discrete probability distribution function has two characteristics. Each probability is between 0 and 1 inclusive. The sum of the probabilities is 1. So to be what? To be probability distribution function, the sum of the probabilities. Diana is here and she's, well, I won't stop the record just because Diana is here. No way. Example 4.1. A child psychologist is interested in the number of times a newborn baby's crying makes its mother after midnight. A newborn baby's crying makes its mother after midnight. So how many times a mother wakes up for the crying of a baby? For a random sample of 50 mothers, the following information was obtained. Let x equals to the number of times per week a newborn baby's cry makes its mother after midnight. Wakes its mother after midnight. That was the keyword that was missing. For this example, x equal lowercase x equals, I don't want to subscribe anymore, 0, 1, 2, 3, 4, 5. P of x equals the probability that x in uppercase makes one on a value. So we have x, the values of x, and the p of x. So that will be y. So 0 when we insert 0, 2, and 50. But the equation is, where's the equation? So just say p of x probably, but y because 11. So that will be the result. The equation is found in this example. That's a problem for this chapter. Table 4.2. Now x in uppercase takes on the value 0, 1, 2, 3, 4. You wait for a second, alright? I guess I can pause this video now. I need to talk to my sister, but we'll continue in a few seconds, alright? So let's continue. x in upper it was x in uppercase takes one the values 0 0 1 2 3 4 5. This is a discrete PDF I guess it's probability function, discrete probability function, because each p of x is between 0 and 1 inclusive. The sum of the probabilities is 1, that is 0, that 2 over 50, 11 over, why 11 over 50, everything is 50, why 50? 50 is the number of probability that we may have, or why is it? Everything is 1. 50 1 divided by 50 or 0 0.0005. Is that what you mean? I don't know. Try it. 4.1. A hospital researcher is interested in the member of time in the number of times the average post up. What is postpone? I guess it's postpone. I don't want to. I don't want to. So let's copy this. Was on. Post up. Post up. So what is not sounding? Cancel. Post up. What is that? So now what is post up? Or how to kind of pronounce it? Period of following surgery. Post operation. Post operation. Post. Post op. Post op. Post op. Post operation. Post operation patient. The average post operation post op post operated patient. Post operated patient. Post period. Post refer to the period of surgery. Post operated patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. Let x equals to the number of times a patient rings the nurse during a 12-hour shift. For this exercise is 0, 1, 2, 3, 4, 5. P of x equals the probability that x takes one value of x in lowercase. Why is this a discrete probability distribution function? Two reasons. But again, we have that fraction over 50. So why it is over 50? 0 and 5. And when it is 5, you have here p of x. I have no idea. Just suppose Nancy has classes 3 days a week. She attends classes 3 days a week, 80% of the time. So for 3 classes, she attends classes 3 days a week, all the time. 80% of the time. 2 days, 50% of the time. The one day, 4% of the time, and no day, 1% of the time. Or suppose 1 week is randomly selected. 1 week is randomly selected. Problem. Let x, the number of days Nancy attend a class, and x takes on that what value. I don't know. It's because let x, the number of days Nancy, and x takes on what values. Suppose 1 week is random. Suppose was 1 week is randomly chosen. Construct a probability distribution table called PDF discrete probability distribution function table, like the one in example 4.1. The table sounds so the table should have 2 columns labeled x and p of x. What does the p of x column sum to? I have no idea. You're telling me. And I don't want to subscribe. Try 4.2. Jeremiah has a basketball practice 2 days a week. 90% of the time he attends both practices. 8% of the time he attends one practice. 2% of the time he does not attend either practice. So that'll be four. I'm not understanding anything by now. Just people just talking. That's everything I've learned so far. So 4.2, mean or expected value and standard deviation. Mouse. Now, so the topic was mean or expected value and standard deviation. Let's go through this topic. So the expected value is often referred to as the long-term average or mean. This means this means that over the long, what is a mean? Long average or mean? An average or mean. So mean is an average. That's simple. This means that over the long term of doing an experiment over and over, you should expect this average. You tossed, and I don't want to subscribe. You toss the coin and record the result. What is the probability that the result is heads? If you flip the coin two times, uh, does does probab does probability does probability tell you that these flips will result in heads one heads and one tail? You might You might toss a fair coin 10 times and record 9 hits. As you learn in topics, probability does not describe the short-term results of an experiment. Probability does not describe the short-term result of an experiment. It gives information about what can be expected in the long term. Demonstrate this. Carl Pearson, I guess that's how you read this. How you pronounce this name? Post operation, post op.
This, Carl Pearson.
Pearson, Pearson. Once, once tossed a fair coin 24,000 times, he recorded the results of each toss, obtaining heads 1 12,000, 12,000 and 12 times. In this experiment, Pearson illustrates the law of large numbers. The law of large numbers. The law of large numbers states that as the number of trials in a probability experiment increases, the difference between the theoretical probability of an event and the relative frequency approaches zero. The theoretical probability of an event and relative frequency approaches zero. The theoretical probability and the relative frequency get closer and closer together. When evaluating the long-term results of a statistical experiment, we often want to know the average outcome. This long-term average is known as the mean or expected value of the experiment, and it is denoted by the Greek letter. How? I am not sure what is this letter, but I don't want to subscribe as well. So let's check this out. Letter is so uppercase M, lowercase. So is that how you read it? Mu. Well, if I what if I pasted here in the translator? Mu, me, mu. So the Greek letter mu. So the Greek letter mu. In other words, after conducting many trials of an experiment, you would expect this average value. The mean mu of a discrete probability function is the expected value. Mu, I don't want to subscribe, equals to the sum of x times p of x. The standard deviation of what is this? Leather, letter, leather, leather, leather. I said leather, but it's letter.
Sigma.
Sigma. Now it's sigma of the PDF is the square root of the variance. The variance, the square root of the sum of of how to say that this it's open 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 square break open parenthesis x minus mu close parenthesis times 2 times p of x and all that enclosed on square brackets. When all outcomes in the probability distribution are equally likely, these formula coincide. I guess that's how you read it. I guess that's how you may
Coincide.
coincide with the mean and standard deviation of the set of possible outcomes. Note, to find the expected value of long-term average, mu, simply multiply each value of the random variable by its probability and add the products. Example, a soccer team player play a soccer team players soccer team a soccer team player soccer 0 on 2 days a week. The probability that they play 0 days is 0.2. The probability that they play 1 day is 50%, and the probability that they play 2 days is 0.3. Find the long-term average or expected value of mu of the number of days per week the soccer team plays soccer. To do the problem, first let's let the random variable x equals the number of days the soccer player plays soccer per week. X takes on the value of 0. I don't want to scribe 0, 1, 2. Construct a PDF table adding a column x times p of x. In this column you will multiply each x value by its probability. So here is the in this column we have 0, 1, and now we have p of x, which is 0 0.2, 0 0.5, 0 0.3, and p. So that to that 0 0.2 we multiply x, which is 0. That will be 0. Now if we multiply 0 0.5 times 1 equals 0 0.5. Now if we multiply 2 times 0 0.3 equals 0 0.6. Table 4.1, 4.5. Expected values table. This table is called an expected value table. An expected value table. The table helps you calculate the expected value on long-term average. Add the last column, x times p of x, to find the long-term average of expected value. 0 times 0. The thing that I said. Yeah, it was the thing that I said. The expected value is 1.1. The soccer team would, on the average, expected to play soccer 1.1 days per week. The number 1.1 is the long-term average or the expected value if the soccer team plays soccer week after week after week. We say mu equals to 1.1. Try it. 4.3. A customer orders 1, 2, or 3 bottles of water. The probability of ordering 1 bottle is 0.6. The probability of ordering 2 bottles is 0.3, and the probability of ordering 3 bottles is 0.1. So it's in decreasing mode. Mm-hmm. And it is in a decreasing mode. Uh, Find the long-term average or expected value of mu or the number of bottles a customer will order. Now we have another example. It's quite big and I have so much to read. So find the expected value of the number of find the expected value of the number of times a newborn baby's cry wakes its parents after midnight. The expected value is the expected number of times per week a newborn cry baby's crying wakes its parents after midnight. Calculate the standard deviation of the variable as well. So we have 0, 1, 2, 3, 4, 5. Those are the times a baby's cry, a baby's crying wakes its parents. A baby's crying wakes its parents. Now we have the p of x, which is multiplied by 50. It's always 50. That's the maximum. Is that the maximum? Because they always place at 50, and it doesn't make sense. No, times x, that will be 0 times 2 over 50, and now we have x times mu squared times p of x. Doesn't, well, I'm not understanding this because you are getting a number without, I guess it's an equation. They always place that 50 and where that 50 came from. Table 4.6, you expect a newborn to take its parents after midnight 2.1 times per week on the average. You expect a newborn to wake its parents after midnight 2.1 times per week on the average. Add the values in the third column of the table. Find the expected value of x, mu, expected value 0, 1, 105 over 50 equals 2.1. Use mu to complete the table. The fourth column of this table will provide the value you need to calculate the standard deviation. For each value x, multiply the square of its deviation by its probability. Each deviation has the format x minus mu, the Greek letter mu. Add the value in the fourth column of the table, 0.1764 plus 0.262 plus 0.0046 plus 0.141458 plus 0.2888 plus 0.1682 1.05. The standard deviation of x is the square root of the sum of, I guess it was beta? No, oh,
Sigma.
sigma. Sigma equals to the square root of 1.05 equal approximately 1.0247. And I don't want to subscribe. Try it. 4.14. A hospital researcher is interested in the number of times the average post-operated post-operated patient will ring the nurse during a 12-hour shift for a random sample of 50 patients. Yeah, that was why 50 patients. It was that simple, but I haven't saw that number in the app in the other examples. The following information was obtained. What is the expected value? So now we have that. Now since we have the number 50, but why we place that for? Because 12-hour shift, 12-hour shift. Hospital research interest number of times the average post-operative patient bring the nurse. So with 0 equals to 4, 4 out of 50. With 0, 0 what? 0. Hospital is interest number of this. Here is the number of times. His p of x. No, it's a random 50%. The following information obtained. What is expected value? I'm not sure why you get that 4, and it seems to double 16. Now here with 3 is 14, 6, and 2, that numerator. Let's see if we have another example that it will be even better. So, for example, 4.5. Suppose you play a game of chance, in which five numbers are chosen for 0 to 9. A computer randomly, a compute a computer randomly select five numbers from 0 to 9 with replacement. You pay $2 to play and could profit 100,000 if you match all five numbers in order. You get a box, $2 back plus 100,000 over the long term. What is the expected profit of paying the game? To do this problem, set up an expected value table for the amount of money you can profit. Let x the amount of let x in uppercase equals the amount of money you profit. The value of x in lowercase are not 0, 1, 2, 3, 4, 5 until 9. Since you are interested in your profit or loss, the value of x are $100,000 and minus $2. To win, you must get all five numbers correct. In order, the probability of choosing one correct number is 1 out of 10. Because there are 10 numbers, you might choose a number more than once. The probability of choosing all five numbers correctly and in order is, so 1 out of 5, 1 out of 5, 1 out of 5 times what times equals to 1 times, yeah, you invert. This is because this is equals to the other, this in what an exponent, no, is powers, in powers. This is an inverted power. 10 minus 5 tens to the power minus 5 equals to those five numbers. No, it was 0, 0, 1. I don't want to subscribe. Therefore, the probability of winning is 0.00001, and the probability of losing is 1 minus 0.00001 equals to 0.99999. Why? So that's the probability. Therefore, the probability of winning is 0.000, and the probability of losing is almost 1. The expected value table is as follows. So there is 99% of probability of losing the game. The expected value table is as follows. Loss and profit. We have loss and the profit. We have in this column we have x, p of x, x times p of x. 2, the probability of x, we have 2 because $2 are out of your pocket, and those 100,000 on profit. So the probability is 0.99999 of losing and 0.0001 of winning. Now the so what is time? What do we multiply this? Minus 2 times 999. It was 1 point almost 2. And here just 1. So table, and the last column minus 1.9998 plus 1 equals to 0.9998. Since minus 0.99998 is about minus 1, you would on average expect to lose approximately $1 for each game you play. However, each time you play, you either lose $2 or profit 100,000. The $1 in the average or expected loss per game after playing this game over and over. Try it. 4.5. You're playing a game of chance in which four cards are drawing from a standard draw are drawn from a standard deck of 52 cards. I already knew that. I'm not I'm not great at playing cards, but I did another I solved another problem with cards. You guess you guess the suit of each card before you guess the suit Suit. This is suit. You guess the suit of suit.
Suit.
Suit of each card. In this contest, what is the meaning? What will be the meaning of this? You get the suit. Oh, right, it's suit. Let's put suit in the context of suiting in the context of cards. A deck of cards. Heart, diamonds, clubs, and spades. In the in the context of cards, suits refer to the distinct set of symbols that categorize the deck in four groups. So refers to distinct sets of symbols. Now it is drawn. The 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 cards are replaced in the deck on each draw. You pay $1 to play. If you guess the right suit every time, you get your money back. And 256. What is the expected profit of playing the game over the long term? Examples. Example from point 6. Just problems. These are just problems with no solutions. So add the table column. I'm not solving this problem. So the just there's nothing here actually. If you consider the fact they they are not solving anything. These open stacks is just well I couldn't understand. I guess if I watch these videos that I want, the ones that I have here, it will make more sense. So let's is binomial distribution. There are fixed numbers or there are fixed number of trials. Think of trials as repetitions of an experiment. Letter N denotes the number of trials. There are only two possible outcomes called success and failure. For each trial, the letter P denotes the probability of a success or on one trial. A Q denotes the probability of a failure on one trial. P plus Q equals to 1, y P plus Q equals to 1. The n, the n, the n trials are independent and are expected using identical conditions. Because the n trials are independent, I really need a sip of water. So we will continue in a few minutes. Why I should be interested? Oh, I forgot to put in pause. Yeah, and now it is a few minutes. I stop. Sorry for making this. Just when I leave, the reason I stopped. I was I thought that I stopped the recording, but when I came in, nothing. It was the same. Was unstopped. Sorry for that, and we will continue now. So uh, the end the end trial are independent and are repeated using the identical notions. Because the n trials are independent, the outcome of one trial does not help in predicting the outcome of another trial. And another way of saying this is that for each individual trial, the probability of P of a success and probability Q of a failure remain the same. For example, randomly guessing at a true value. Statistics statistics questions has only two outcomes. If a success is guessing correctly, then a failure is guessing incorrectly. Suppose Joe always guesses correctly on any statistics true or false question with probability p equals to 0.6, then q equals to 0.4. This means that for every true false statistics question Joe answers, his probability of success p equals to 0.6 and his probability of failure is equal to 0.4. Remain the same. The outcomes of a binomial experiment fit a binomial probability distribution, the random variable x, the number of successes obtained in the n independent trial, the mean mu, and average of beta. I'm not just beta. It's, it's not beta.
sigma,
Sigma. Sigma. For the binomial probability distribution are mu equals to n times p and mu square equals to n times p times q. The standard deviation of sigma is then sigma equals to the square of n, p, and q. Any experiment that has characteristics that has characteristics any experiment that has characteristics 2 and 3 and where n equals to 1 is called a Ber Bernoulli trial. Is it Bernoulli trial? No, it's not.
Bernoulli trial,
Bernoulli
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 trial,
trial is this. I guarantee I 100% put my all the eggs on the basket that this name is French. No, French, Italian. Bernoulli,
Bernoulli
obviously
trial,
Italian. Bernoulli trial, named after Jacob Bernoulli, who in the late 60s studied them extensively. A binomial experiment takes place when the number of successes is counted in one or more Bernoulli trials. Bernoulli, Bernoulli, sorry,
Bernoulli
Bernoulli,
trial,
Bernoulli trial, Bernoulli,
Bernoulli trial,
Bernoulli trial. Example 4.9. At ABC College, the withdrawal rate for an element for elementary physics. I never got the courage to speak in public, so one of the ways I'm I'm betting on is speaking to YouTube.
withdrawal,
Withdrawal. So I'm improving it a lot since I create this YouTube channel. So withdrawal with
withdrawal,
withdrawal 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 rate from an elementary physics course is 30% for any given term. This implies that for any given term, 70% of the students stay in the class for the entire term. A success could be defined as an individual who withdrew the random variable x equals the number of students who withdrew from the randomly selected elementary physics class. Triad 4.9. The State Health Board is concerned about the amount of fruit available in school lunches. 48% of schools in the state offer fruit in their lunches every day. This implies that 52% of do not. What would a success be in this case? Example 4.10. Suppose these are only examples, but let's see if I have a problem that have a solution. I guess this one, but this is just a problem. If not solved, and so show hidden solution. Oh right, show hidden solution. That's the solution. So until this point, I wasn't aware that there was a an option for show hidden solution. So let's go through this one and let's see if the hidden solution actually works. This is the last section I will read binomial distribution, and I will finish everything. Just I have to watch those videos and we will be over, but those videos we won't explore it in this video, just the problems. And if you keep following the following up video, I have a board on my back and I really love to share it with you how it might look like. So let's finish the with let's finish this up with this. I guess we don't have anything else. Everything seems to be the same. Yes, problems. And well, let's go through one with a hidden solution. Let's this one. In the 2013 Jerry's Artarama Art Artarama Art Jerry's Artarama Art supplies catalog. So no microphone, just
2013 Jerry's Ardorama
Ar
Art Supplies.
Artarama Art Artarama
2013 Jerry's Ardorama Art
Artarama
Supplies.
Artarama Artarama Art supplies catalog. There are 560 pages. 8 of the pages feature signature artists. Signature artist. What is a feature signature artist? I guess well known or renowned artist. Signature. Signature artist. What is a signature artist? A signature artist. Artist signature. Signature artist. Fine artist. So I guess I have to put it here. Signature artist meaning put it meaning a person emblem of authenticity and ownership. An artist's signature is a distinctive mark of the inscription that an artist signature artist a signature artist. Suppose we randomly sample 100 pages. Let x equals the number of pages that feature signature artists. What value does x take on? What is the probability distribution? Find the following probabilities. The pro the probability that 2 pages feature signature artists, the probability that at most six, 6 pages feature signature artists. The probability that at most 6 pages feature signature artists. The one is that 2 pages feature signature artists, and for signature artists, I guess is well-known artists, renowned. The probability that more than 3 pages feature signature artists. Using the formula, calculate the mean and the standard deviation. So those are the 2 topics that I need to work this this week. X equals to 0, 1 until 8. X in uppercase. What is this signal?
Tilde.
Tilde. It's the tilde. Tilde. That's the tilde? Oh, so the tilde is not the. But what about this?
Tilde.
Tilde? So this is a tilde. And what about the. Well, I'm not sure. B times 100, comma 8 over 560. Why 560? 560 pages. That's the 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 that's the top. That's the maximum amount of pages. The all the pages there are all the pages found in the book or the catalog. So p x equals 2 by no binomial PTF 100 over 8 over, so I don't understand this. So let's stop this recording until this point, 51 seconds, and for the following video I will explain the two topics: the the deviation, that will be the standard deviation, and the other one. So these two videos: mean or expected value and standard deviation, and probability distribution function, the PDF. Those two videos. So you just stick until this very end. I mean, that my voice captivated you. We will continue with this series. Thanks for watching, and thanks for hearing.